Space is vast, big, like enormous. You can't possibly fathom how enormous it is. It's so large it blows your mind. That trip to the chemist might seem far from home, but in cosmic terms, it's a mere drop in the ocean of space. According to astronomers' calculations, only about 5% of the cosmos is made up of baryons, the entities that make up atoms, which make up molecules, which make up everything we can see, touch, smell, or taste. 20% of the universe is made up of dark matter, an enigmatic material that only exerts its influence through gravity, and the remaining 75% is made up of dark energy, a field that encompasses all other regions. Even though it sounds like something out of a science fiction novel, it's actually the most plausible account for the major characteristics of our world. Dark matter and baryons gravitationally cluster together, while dark energy drives everything apart. And that's causing the growth of our universe to not only continue, but speed up. To calculate the acceleration, scientists mapped the cosmic background radiation left over from the Big Bang with the Planck telescope. Findings from the Planck expedition confirm the existence of dark matter and dark energy, though their nature remains a mystery. In a few tens to hundreds of billions of years, all but the closest neighboring galaxies will have shifted out of reach. No matter how quickly future humans might journey, we will never be able to reach anything else. If an extraterrestrial civilization ever reaches the stage where it needs entire galaxies as energy sources, it may have to abandon its home galaxy and exploit other galaxies for stars, rearranging the universe itself, according to a recent study. Far-fetched? You're probably just very well prepared for the worst-case scenario if you're at the level of thinking that causes you to fret about the stars disappearing. We know the universe is at least 30 billion light-years across, and it may be endless. This leaves a lot of room for aliens and dark energy. What's in this space? Not much at all. Hydrogen, however, makes up the vast majority of the universe. Hydrogen is the least dense element because it consists of just one proton and one electron in rotation around each other. From the heated, crowded stellar nurseries where new stars are formed, to the frigid, delicate gaps between galaxies, hydrogen can be found everywhere. 75% of all elements in the world are made of this element, making it the most prevalent. According to American author Harlan Ellison, hydrogen and stupidity are the most prevalent substances in the cosmos. However, most hydrogen atoms in space are so dispersed that they cannot be seen by telescopes. The question then becomes, how can we confirm their existence? That relies on whether you're dealing with ionic, atomic, or molecular hydrogen. When a hydrogen particle is divided into protons and electrons by a neighboring heated, brilliant star, the result is ionic hydrogen. Hydrogen atoms are formed when the temperature of the cosmos is low enough for protons and electrons to rejoin. Giant clouds are the source of molecular hydrogen, H2, the same type of hydrogen that exists on Earth. Carbon monoxide, CO, and more complex compounds like ethanol, C2H6O, are among those we occasionally discover in these clouds. Yes, scientists are on the hunt for alcohol in the cosmos. Because of the specific frequencies of light that atomic and molecule hydrogen receive and release, their presence can be easily detected by scientists. Ionized hydrogen is nearly undetectable, but it has one remarkable effect. It makes objects sparkle. They say space is just a big vacant vacuum. If we know it's packed with stars, black holes, nebulae, and galaxies, then how vacant can it be? The night sky is filled with the possibility of seeing stars and maybe even a few planets. Planets stand out from the stars because they don't flash like the rest of the galaxy's luminaries. The stars are so far away that their light must traverse an extremely narrow path to reach us. As the light moves through our ever-changing atmosphere, it experiences distortion that causes the brightness to fluctuate from moment to moment. The distance at which planets are seen from Earth makes it impossible for the glimmering of their radiation to occur. For tens of thousands of years, indigenous Australians have relied on the glimmering of the stars to predict the coming day's temperatures and weather. The same is true of radio signals, which are generated by galaxies. In the same way that our atmosphere scatters light from the stars, the electrons of the ionized hydrogen disperse these waves. The apparent blinking of distant galaxies reveals to scientists that space is filled with extremely dispersed ionized hydrogen rather than being completely void. Exactly what is the deal with the distance between atoms? What does a void consist of? What's the tiniest measurement that can be taken? Is space itself structurally seamless, or is it composed of infinitesimally small pixels? Now comes the strange part. Quantum physics is something that I believe I can fairly assert that nobody understands. The theoretical scientist Richard Feynman once said, "The universe appears to be a bizarre quantum froth on these dimensions, with virtual entities appearing and disappearing in accordance with the principles of quantum physics." However strange it may seem, quantum physics effects can be measured in the lab, for example via the Casimir effect. But the limit of the plates has an effect on the sea of virtual particles anticipated by quantum physics. Less virtual particles can be produced in this restricted area than outside the plates. As a result, the greater number of simulated electrons ricocheting off the exterior pushes the surfaces closer together, despite the fact that according to any other readings made inside or outside the plates, there is nothing there. Perhaps this vacuum energy is the secret to unlocking the mystery of the universe's dark energy at the most fundamental levels. Science has struggled for decades to find a solution to the issue of reconciling the vacuum energy with dark energy. Scientists agree completely on one thing: vacant space is extremely complex. Enjoyed this video? Like to learn more? Make sure to subscribe, and I'll see you soon. Thanks so much for watching, and if you made it this far, you're a real one.